So I was driving down Taft Street when a compact car driven by Mr. Gonzalez, by Mr. Garcia, passes the red light at the intersection. So I start freaking out and I hit the brake to avoid the car accident. But the next thing I know, Mr. Garcia hits me. And he's claiming that I didn't stop, but I did, and it was his fault.
So can you tell me how fast you were going?
I was definitely not going too fast because it's a school zone and I would not want to run over a child.
Are you sure about that?
I am positive.
Good morning, Mr. Garcia. My name is Officer.
Oh, hell no. Can I get a different officer? I don't want to do this today.
Well, I'm here to discuss your accident on January 14, 2019. Can you tell me your side of the story?
So let me tell you what happened. So we were at the light, right? And I'm sitting there in my car and I'm at a red light, right? And I completely stopped. My car is completely not moving. I stopped for this red light. Then I look and start to go. And this Miss Wakefield or whatever her name is just keeps on coming and just hits me right head on. And she says she was slowing down, but she wasn't slowing down at all. What is that? Can we go?
Now let's go back to the accident one more time. Since the truck's manufacturer claims that the coefficient of friction for the truck tires is only 70% of the tires, we multiply 0.7692 by 0.7 to get a coefficient of friction of 0.5385. To calculate the mass of the car, we divide the weight of 69,700 newtons by 9.8 to get 7,112.2449 kilograms. To find the force of friction of the car, we multiply the coefficient of friction 0.5385 with the weight of 69,700 newtons, which gives us about 37,533.45 newtons. Now that we have the force of friction and the mass of the car, we can find the acceleration by dividing the force of friction $37,533.45 by the mass, 7,112.2449 kilograms, which gives us an acceleration of about 5.2773 meters per second squared. Now that we can use the equation v squared equals v naught squared plus 2a times x minus x naught to find the speed of the car after the collision. Now we just plug in 0 for v squared, 5.2773 for a, and the skid of 11 for x minus x naught, which gives us a speed of about 10.775 meters per second. Lastly, by using the conservation of momentum, we can find the speed before the collision. This is found by using an equation which is the velocity of the truck is equal to mv of the car plus the final mass times velocity of the truck, all divided by the mass of the truck. Now we plug in our values, which is .7551 times 11.1187 times cosine of 33 degrees plus 712.2449 times 10.775 times the cosine of 7 degrees, all divided by 7,112.2449. Then we plug it into our calculator and find that the velocity before the collision of the truck was 12.49 meters per second.
If we were to look back at the car accident and divide the 100 Newton force required to drag a 130 Newton car tire across the pavement at a constant velocity by 130 Newtons, we would get a coefficient of friction equivalent to 0.7692. To calculate the mass of the car, we divide the weight of 13,600 Newtons by 9.8, which would give us 1,387.7551 kilograms. To find the force of friction of the car, we will multiply the coefficient of friction of 0.7692 with the weight of the car of 13,600 Newtons, which would give us 10,461.12 Newtons. Now that we have the force of friction and the mass of the car, we can find the acceleration by dividing the force of friction of 10,461.12 by the mass of the car, which is 1,387.7551, to give us an acceleration of 7.5382 meters per second squared. Now we can use the following equation to find the speed of the car after the collision. So we plug in 0 for velocity squared. We plug in 7.5382 for acceleration, and we plug in the skid of the car for position. This would give us a speed of 11.1187 meters per second after the collision. Lastly, by using the conservation of momentum, we can find the speed before the collision. So the speed before the collision of the car is equal to the mass times the velocity of the car, final, plus the mass times velocity of the truck, final, over the mass of the car. Now we plug in our numbers. So the mass is 1,389.7551, and the velocity is 11.1187, and this is at a cosine of 57. And we add the mass of the car, of the truck, which is 1,112.2449 times the velocity of 10.775. That goes to a cosine of 85. And we divided by 1,387.7551 to give us the velocity of 12.79 meters per second.
According to our calculations, both drivers are at fault. Mr. Garcia claims to have been in a full stop before entering the intersection. However, his speed before the collision is 12.70 meters per second. He also claims that Ms. Wakefield did not slow down prior to the collision. However, this is correct because Ms. Wakefield was accelerating at 7.538 meters per second squared prior to the collision. Ms. Wakefield claims to have been braking before the collision, which again is wrong because her acceleration had a positive magnitude. She also claimed that Mr. Garcia did not stop at the flashing red light, which she's correct about because not only was his speed before the collision 12.79 meters per second, but his acceleration was also 5.27 meters per second squared.